Chris Martin is a senior research engineer for the Energy and Environmental Research Center. Chris, how you doing?
Oh, I'm doing very well.
So I've got the popcorn, and now you're going to be the movie, and I'm going to learn a little bit about reducing water use in heating and cooling systems through hygroscopic cooling. That's a $64,000 word there. What is hygroscopic?
Well, yeah, sure. So hygroscopic, if we kind of break it down, the hygro part refers to water, and then the scopic means absorbing. And so a hygroscopic substance is one that likes to seek out and retain water within it. And so that just refers to the medium that we're using in this technology that we have for cooling towers. And it likes to hold on to water, and so it prevents an excessive loss of water from our cooling system.
So if you perfect this, get it right, and reduce water use in heating and cooling systems, basically we're saving water. You use less water. Is that what you're telling us?
That's by far the biggest benefit of this technology. Yes.
Now I didn't know this, but evidently HVAC systems in the bigger buildings use water for their cooling towers. 28% of the water used in office building goes to heating and cooling systems, and 13% is all to kitchen and dishwashing, or 22% to watering the lawn, 37% for domestic or restroom uses. So you got a pretty good sized number that's in the actual heating and water cooling system for a whole typical business, right?
Yeah, that's correct. I mean, that certainly varies somewhat with the specific building you're talking about. You know, those numbers you're referring to are for kind of an average kind of office-type structure. But yeah, these larger buildings, you could think of these cooling towers as like a sweat gland for the building. They evaporate water, and that's how to get rid of the heat that's generated within the buildings. And they're a surprisingly large consumer of water. It's not typically an issue up here in North Dakota, but where we're doing this project, out in California, it's a huge issue, and they're actually passing laws about the way the types of cooling towers that people have to put in and the way they have to be operated in order to maximize water savings.
Very interesting. Now, the Department of Defense has funded a research project for 2 years. Why would DOD fund something like that?
Well, it's for them. It's just the bottom line. They're essentially the nation's largest landlord. They own a significant number of buildings across the country, and so DOD's electric bill and water bill is in aggregate, of course, is the largest in the country, and so they fund programs like ours to demonstrate novel technologies that they can then replicate at other locations, with the ultimate goal of saving them money from their operating budget.
What's the difference between wet cooling and dry cooling?
So wet cooling would be what we're talking about today, with using a cooling tower to reject heat from the building to the atmosphere. Dry cooling is actually something that most people are probably very familiar with. Like any home-sized air conditioning system is going to be dry cooled. If you go out behind your house to the condensing unit that's out next to your house, that's a dry cooling system for your house. And so if you imagine that same system scaled up for a very large building, instead of a fan and coils, you'll have this cooling tower where you're evaporating water to get rid of the heat.
So you're making some sense here on why this would obviously be a good thing. And if you have areas that have a drought, obviously you're looking to do everything you can to do it less. So I would assume you also probably have less costs. Would that be right if you get this to work?
Well, you'd have lower operating costs. That's what we're hoping to prove with this demonstration. Our technology, it would be kind of in a category of a premium cooling tower, if you were to think of it that way. So it'll cost you a little more up front with the equipment, but over its lifetime of operation, it's going to save you more than its initial cost in the cost of water. And folks like the Department of Defense, that's how they tend to look at things on a life cycle cost basis, and that's where something like this would really make sense.
So is EERC doing this for DoD? I mean, as part of your research, a part of their program, or are they separate tracks?
No, it's so the Department of Defense is funding a demonstration of our technology at one of their locations, actually at two of their locations. The technology itself came out of, it's an interesting offshoot of some other work that has been going on here at the EERC relating to water use at power plants. You know, that's normally the area that we work in is coal-fired power plants, and they are also a very large user of water. And so we had a number of programs looking at water use in power plants that led to this technology, and this opportunity with DoD just happens to be an interesting application of that technology.
So what kind of a track, when you guys do something like this, to say, hey, here's a problem, we think we have a solution, we're doing a little research project to test it out, beginning, middle, and end, how long is that?
Oh, well, this, from the beginning concept of the idea, I started work on this probably 2011 time frame, is when we were in the laboratory doing some literal, tabletop experiments of the idea. And it graduated through, I would say, probably 3 rounds of, various levels of funding to get to the stage we're at now.
Very interesting. Anything else you want to tell us about this project, Chris?
Well, I think we hit the high points, and I certainly hope once we transport this out to California that I'll be able to, post some interesting pictures of the site out there and have a success story to report back about. Fascinating.
Looking forward to finding out more about it, and appreciate all the good work everybody is doing at the Energy and Environmental Research Center on the campus of UND. Chris Martin, Senior Research Engineer, our guest. Thank you, sir.
Yeah, thank you very much.